Have you ever questioned the nature of reality? How the world around us works at its most fundamental level? Picture this: a realm where the smallest particles of the universe dance and twirl in a ballet of uncertainty, where the ordinary laws of physics we're accustomed to just don't apply. This isn't some distant galaxy or an alternate universe, but the world of quantum mechanics. Quantum mechanics, a cornerstone of modern physics, is the theory that seeks to explain the behavior of these minuscule particles. It's a realm where particles can be in two places at once, where they can spin in two directions simultaneously, and where observing a particle can actually change its state. It's a world that defies our everyday understanding of reality, where the rules seem more akin to magic than science. But this isn't a fairy tale. It's the puzzling, fascinating, and utterly mind-bending world of quantum mechanics. Quantum mechanics, in essence, challenges our perception of reality as we know it. Imagine tossing a coin. When it lands, it's either heads or tails, right? But what if it could be both at once? Welcome to the world of quantum mechanics, where the traditional laws of physics take a backseat to bewilderment. Here, we encounter the concept of quantum superposition, which is a bit like our coin being both heads and tails simultaneously. In the quantum world, particles don't just choose one state or the other. They can be in multiple states at the same time, until they're observed. It's as if our coin is spinning in midair, both heads and tails at once, until we catch it and look, forcing it to choose a side. But it gets even weirder. Particles can also be in two places at once. Imagine if you could be at home and at work simultaneously. Talk about multitasking. This is the reality of quantum mechanics, where the strange becomes commonplace and the impossible becomes possible. In the quantum world, it seems anything is possible. Scene script. Think of a pair of dice. You roll them, and the result on one has no effect on the other. But in the quantum realm, things behave differently. Let's imagine these dice are quantum particles. Unlike regular dice, when you roll these quantum dice, they can become entangled. Now, what does that mean? Well, it's as if the dice are linked in such a way that the outcome of one instantly influences the outcome of the other, regardless of how far apart they are. Fascinating, isn't it? This is the essence of quantum entanglement, a phenomenon that puzzled even Albert Einstein, who famously referred to it as spooky action at a distance. No matter how far apart these entangled particles may be, a change in the state of one particle will instantaneously affect the state of the other. So, in this quantum universe, distance may not matter as we think it does. Scene script. Imagine trying to watch a hummingbird's wings. They flutter so fast that you can't see them clearly. This is somewhat similar to Heisenberg's uncertainty principle. Now let's delve into this principle. Picture yourself trying to snap a photograph of the hummingbird in flight. You can either capture the bird's position, frozen in time, or you can capture the blur of its wings, indicating its speed. But you can't capture both perfectly at the same time. This is the essence of Heisenberg's uncertainty principle. In the quantum realm, we can't know both the precise position and the exact momentum of a particle simultaneously. The more accurately we know one of these values, the less accurately we know the other. It's as if nature herself is saying, "I'll allow you a glimpse, but not the whole picture." It's a quantum quirk that challenges our everyday logic, where we're used to knowing both where things are and how fast they're moving. In our quantum world, it appears certainty is not always a given. Quantum mechanics, as we've seen, is not only mind-boggling, but also fundamentally changes our understanding of reality. We've delved into some of its strangest phenomena, starting with the concept of superposition. This principle tells us that particles can exist in multiple states simultaneously, only committing to one when observed. This is like being in two places at the same time, a notion that shakes our understanding of reality to its core. Next, we explored the spooky world of quantum entanglement, where two particles can become inextricably linked, no matter how far apart they are. This connection is instantaneous, defying our traditional concepts of space and time. Finally, we grappled with the uncertainty principle, the idea that we can never know both the exact position and momentum of a particle at the same time. This principle underscores the inherent unpredictability of the quantum realm. So the next time you look around, remember, beneath the ordinary lies an extraordinary quantum world.